Hello everybody, welcome back to another Layer by Layer. Thank you so much for joining me today. Today I have Circuit Playground here. This is Circuit Playground, the Express version, the new version of Circuit Playground. Featuring the Atmel SAMD21 chipset. It's got more SPI flash as well, so we can run some awesome things like Circuit Playground and MicroPython. So in today's tutorial, I wanted to show you guys how I put together how I redrew this component and all the components on the board in Fusion 360. So you can see up here in my little window thing here that I can't grab, but I have modeled it in Fusion 360. So I wanted to go and show you guys how I did that and eventually create an enclosure like this one here. So this little enclosure is very, very simple. Let's look at the top part first. There's a series of holes here, and these holes are little cutouts for exposing some of the sensors and buttons. And on the bottom of it, you can see there are a total of 4 of these little nubs. These little nubs are kind of little pins that go inside of the pads here. So if I orient it in the right way, this way, you can see how the cutouts are exactly in the right spot for exposing the buttons, the switch, the reset button, the buzzer, the microphone, and even the color sensor. Very, very cool. And then the bottom part has a little smiley face on it because it's so happy. And it has 2 nubs on this side, so the other one had it on this side. So when you snap these 2 together, you get this really nice alignment, and they kind of snap nicely together. And it is very, very thin as well, so that's why we have kind of cutouts for the JST connector and the micro USB port as well. So if we plug it in, you might notice, wait, what about the NeoPixel LEDs? Well, this material is actually translucent, and it's made out of coffee, so you get this really nice light diffusion as well. So the LEDs don't really need holes because they can be diffused to get this nice soft glow. So pretty cool. This is what we're going to kind of work on today. But the first thing I kind of want to do is to show you guys how I go about modeling an enclosure like this. First, you need to kind of have this in CAD and have tech drawings and things. So let's take a look at my screen here. Let me flip over to it. So if you go to Adafruit's learning site, you can see that most of our boards have learning guides with libraries, demo codes, of course. But if you go down to the downloads page, you can see we normally have schematics and tech drawings, or fabrication print as it's so labeled here. If you look at it, you get a kind of an idea of what the board diameter is and maybe the distance between some of the mounting holes, which is kind of great. But if you want to redraw this part and you want an enclosure that has precise openings for the buttons or any of the sensors, you do kind of have to know more than this. So thankfully, Adafruit is open source, and we do release all the PCB files. So if you look here under source, PCB files in EagleCAD format. Yep, it is on GitHub, and you can download it. The Circuit Playground Express version, however, is still being finalized. I believe it is finalized, but we will have that out when the board is released. So I got early access to it because I need to make an enclosure for it. Right. Or you could also search on Adafruit's GitHub for any other components. Most of the projects that we work on that are revolved with 3D printing, we do try to come out with the like a CAD file for the circuit boards. Not all of them are there, but hey, we have some of them. So what I'll be using today is actually EagleCAD to look at the board and inspect it and get the positions for each component and then kind of redraw them, look at the footprints and things like that. So if you haven't heard already, Autodesk now has purchased EagleCAD Soft, and it is now version 8.0. It is still a free download. You can download it for Windows, Mac, and Linux. I've already had downloaded it, and in the future, we'll probably be looking at KiCad as an open source solution, an alternative to Eagle. Eagle is awesome and great and things, but KiCad is definitely worth taking a look at as well. But in this tutorial, we're going to look at EagleCAD first. So I already have EagleCAD open. You kind of start off with this control panel. You know, there's libraries and things already built into it, but let's just go ahead and go to File, Open Board, and look for our RevD board. So RevD is the latest version of Circuit Playground, and it's not searching. Why aren't you finding it? Uh-oh. Normally I would have it all ready and prepared, but it looks like we might not have things ready. Give me a moment here, folks, while I look for it. This is a live stream, so things kind of don't work sometimes. Yep, no pressure, guys. Where is the board? That's what we're looking for. I honestly can't find the board. Okay, here we go. We're getting there. Alright, cool. Okay, well, I was able to find it, so let's go back to Wirecast and take a look here. Alright, so I do have it. We just want to work with the board file first, so typically we get a schematic and a board, but we could just open the board first. So here's what it looks like. This is what it looks like when you first kind of open it. And just for a refresher on how to kind of navigate around the EagleCAD environment, it's a lot like Fusion 360. So you can zoom in using the scroll wheel, and you can pan using the middle mouse button like this. It's a little slow today, but hey, if you go into Fusion, you can see it's pretty much the same. So we get the middle mouse button to kind of move around and scroll wheel to zoom in and out. Okay, we get that. So let's take a look at the next thing, which is kind of figuring out where things are. So one thing I like to do first is to kind of hide some of the clutter and things. Mainly the traces. They're a little bit kind of in my way, and I need to make sense of where the components are, not really where the traces are. So we can turn off the traces easily by going into the layer settings in this little toolbar over here. We have this thing called layer settings. And this is what all the layers look like. So they have numbers here and they have names associated with them. The blue selected things are actually the layers that are enabled. If I click on the one and then I click on apply, I can quickly kind of hide that layer. I'm not deleting any of the traces, I'm just hiding the layer. You can do that for the bottom, maybe even the pads. Or actually, let's leave the pads, turn off the vias, hit apply, and I'll hit OK. Now I kind of get a much cleaner look at where all the components are. The next thing I want to do is show you guys where the origins for everything is. So if you look at all these components, you can kind of get a sense of what they are. Like I think that's a button. But if you look at all of the little squares and all the components, they have these little crosshairs. These are the T origin layer. These are the center. Most of them are in the center of the component. And if we use the info inspect tool, which is over here in the top toolbar, and if you click on one of those crosshairs, you get a properties panel for a given element, that whatever you clicked on. So in this case, it's switch 1, and then the next thing is position. So you get 2 input boxes here with 2 numbers. So this is actually the X coordinate and the Y coordinate relative to the board. So, and then you get some other things like what package is and what library is it from. Those are great. But the main thing you want to know is sort of angle and position, right? I'm going to hit OK. I didn't really change anything there. The next thing I want to show you guys, you see all those crosshairs, right? You only notice that there's one crosshair that has dotted lines, and that's this little guy right here. So what is that? That is the kind of 0, 0 coordinate of this document. So most boards are going to kind of be in this area, but because this is a circular board, it kind of makes sense to have it in the center of the document. So actually what I have here is I kind of put it together a little grid type thing. Hopefully I don't have to search for it for 2 minutes, but I hope I can just open it. Yeah, this guy, XY grid. So take a look at this chart. I kind of try to give you a visual of what the kind of thing looks like. So here's a little crosshair, and you can see the Y-axis is going up that way, and the X-axis is going this way. Typically with an EagleCAD file, and even with machining like in CNC, your origin of your document should always be on the lower bottom left of your document. So if this, let's say this is the button, you see how there's a cursor in the middle now? To be 0, 0 would have to be kind of this way. And then going on the X, you kind of adding to like 100 or whatever value. And then going up, you add more value. So if you're going this way past the document, you're actually going in negative values. So just kind of a quick little look at kind of how the documentation orients are. So So that's why when you look at the button, it's going to have like a negative value, like negative 0.39. And you'll notice that these are, what are these? Are they inches? Are they millimeters? They're inches. If you go into the grid icon here and open that, you can kind of switch this around. So right now it's set to inches. If I change the size from inches to millimeters, it'll automatically change that grid size. I'm going to turn the grid on as well by turning display on. And I'll hit OK. Now if I zoom in, I get a really nice small grid, and you can see kind of how all of the parts are relative to the grid. But yeah, that's just kind of a good thing to know, is where the grid is and where objects are relative to that, that center origin. So if I were to click on this guy, which is most likely the @SAMD 21, if I click on that, yep, that is the @SAMD 21. See? Yay. You can see that it's on 0 and then 9.4 on the Y. So it makes sense because it's right in the center of the kind of crosshair and the origin, and then it's going up on the Y by 9. So by just doing that, now we can kind of figure out where all of the components are. If of course the component is centered correctly. Some of them aren't, but most of them are. So that's how you can kind of figure out where a switch is in kind of relative to the board. So okay. Now the next thing I want to do is, well, how do you figure out how big an object is? What is the width and the height of the SAMD? If you go into the properties panel, actually no, what you do is, I think if you right click on it, you can say open package, and that'll give you an editor, but we don't have the library to do that. So instead of kind of searching for it or grabbing it or asking somebody for it, we can use the dimension tool to figure out how big this thing is. So I'm going to click on the dimension button, but when I do that, our bottom layer showed up. And if you look at the top here, now we have a bunch of these tool options, and these are options particular to the tool, and you can see that layer 16 bottom is active. I'm going to change this to layer 47, which is measures. This is sort of the layer that's kind of dedicated to measures and dimensions and things. So I'm going to click on that, and then I'll bring back the thing again, a little layer thing, and turn off the bottom, hit OK. You notice now we have all these dimensions and stuff that showed up, and these are just kind of ones that were there from the previous Circuit Playground version, but we can use this tool to figure out how big something is. So for example, the @SAMD21, how big are you? So with the tool still selected, if I wanted to find out what the width is, I can click on the far edge here once, and then kind of just move my mouse over this way. You can see it's about 7 millimeters. And then we can do the same thing over here. I hit escape key on my keyboard, by the way, because I don't want to actually put one here. And yeah, it's about 7 millimeters on the X and the Y. But how deep it is, how thick it is, that's where you kind of have to either look that up or use something like calipers to figure out how thick something is. So just by doing those two things, knowing the position of it and then using dimensions, you can really figure out and fine-tune where everything is. So that's pretty cool. All right, so that's kind of how I put together this in Fusion. So if you look in Fusion, the CAD file here, you can see all my bodies are kind of separate. So I have just the PCB and just the micro USB ports. Everything is its own object. NeoPixels are their own object. And the same thing with the sketches. All of these objects are derived from sketches, so it makes sense to kind of have everything be its own thing instead of drawing everything with one sketch. Which I have done before in the past. I wouldn't recommend doing that now because there's just so many components here. But they're not every component, like some of the resistors and maybe capacitors. They're not here. It's just mainly the sensors and some of the buttons and things. So what I'm going to do next is kind of show you guys one other method of sort of a quick method of getting Eagle like this board drawing. How can I quickly get this board into Fusion, right? So one way to do that is using the export option. I'm going to go ahead and turn off the layer 47, which is our measures. We don't need that. Whatever is kind of seen right here, when you export it, it will be there. So if you don't want your traces to show up, just turn off the traces layer. And I'll probably even turn off this pink one, bottom place. I'm going to remove that as well. Okay, cool. So now I have kind of the main things that I want. All right, now I'm going to go up to File. I'm going to go Export and then DXF. If you guys are or AutoCAD users, you probably know DXF format. Oh yeah. I'm just gonna leave all these checkboxes on or whatever. I'm gonna leave those on. I'm gonna leave the units on millimeters because I like millimeters, and I'll save it in the spot where the board is, and I'll hit OK. Overwrite it because I've already done this. And now in Fusion 360, I made a new document. Now I can actually import that by going under Insert and then Import DXF. It'll ask me what plane do I want. I want on the bottom plane. And then I'll click the little folder thing. And nice, recent places. Here's the DXF file that we just exported. I'm going to hit Open. Give it a couple of seconds because Fusion is figuring out where all the layers are and kind of redrawing it. So there it goes. Awesome. And then I have a little options here. I have I can look at layer 20, 23, 17. These are the ones that were imported in. You have the option to turn them off or on. Layer 20 is the outline. Layer 23 is, I don't see any difference, so I'm going to leave that off. Layer 17 looks like is the mounting holes. And layer 51 is like the buttons and some other things. NeoPixel. So I'm going to hit OK. And it's thinking, still thinking. Let's take a little bit. It's a little bit of a slow thing going on here. So this is just a quick way to reference the positions and things for your components. So I wouldn't recommend kind of drawing this. We could export this or extrude this out and then kind of work within it. But I wouldn't recommend doing it, because it's a little kind of finicky. You can see that there's a lot of extra lines and things that you might have to clean this up a little bit to kind of get exactly what you want. But this is just one method that I guess you could use to kind of redraw components, is to get a DXF out of Eagle or whatever CAD package and then get it into Fusion and then kind of work around that. But some things aren't correct. You'll notice that these holes here, these mounting holes, if I extrude it out, you'll see that the radius, or the diameter rather, is what? 2.108. That's wrong. It's actually 3.2 millimeters, and I know that because I use calipers, and for whatever reason the DXF doesn't produce a proper correct circle. There are some options here when you do export the DXF of how do you want to use wire widths or fill areas. I haven't really experimented with it too much. Maybe there is a way to get the correct diameter of the holes, but it's not right by default, so you do have to keep in mind of that. Okay, so the next thing I'm going to do is just kind of show you guys how I redrew it and maybe just draw one or two components, because I don't want this to be too long. So I start off with a sketch, obviously, and then it's going to be on the bottom. I'll start off with a circle here, circle tool, and I definitely start off the center, just like how our document is in the center here. I would start off in the center, so I would start off there, and by since it is 2 inches, I could either type in 2 inches and it'll kind of do it for me, which is nice. So you can interplay millimeters and inches, so 2 inches, hit OK. So it's 50.8 millimeters. All right. The next thing I'm going to do is kind of figure out where the mounting holes are. So one way to do that is you could, of course, say, okay, let's look at this not mounting hole, but one of the pads. So you'll notice that there is a crosshair here, but it is it's not in the center of the circle. What's the deal with that? Well, if we turn on the top layer, you can see that it's actually a little kind of component. It's an element that has a pad shape, like this specific shape here, that has a curved edge here, and it's centered this way. So it's not centered to the green pad, but it's centered to the whole object. So how do we figure out where it is? So one way I figured out how to do it is a kind of a little tricky, messy way to do it, but it worked out for me. I'm going to change this grid here to inches and then put 2.5 so I get a finer sort of grid here. What I ended up doing was making a circle and then lining it up with the pad so that I knew it was the best place. Now this might not be the most optimal way to do it, but hey, this is how I know how to do it. And it doesn't even matter how big the circle is, as long as it's in the center of it. So now that I drew it out on layer 19, I'm gonna move it. Hopefully I can move it. And let me hide the top again. Okay, maybe now I can move it better. Nope, I'm just moving different things now. Because I drew it on this kind of weird layer, I'm kind of having a little problem here with it. Okay, so there's that. Let me see if I can hit move. All right, now I'm moving it. So try to kind of get it in the right spot. That looks pretty dead on actually right there. So now that I have that, I can inspect it and find out where the position is. So I know it's 0 on the X, and then, well, because it's going on this way, it's saying it's negative. It's actually a positive value if we do it in Fusion. So I'm going to copy that to my clipboard. I believe that is inches. Yeah, that is inches. So now in Fusion, I'm going to go in here. I already know my radius is 3.2, so I'm going to draw on the 0 of the X axis and then just put 3.2. It already knows it's millimeters. And then what I'll do is I will say I want a distance using the dimension tool, the sketch dimension tool. I can say I want the center of this to be a certain distance from the center of the board. So right there. So now I could just paste in that value and say it's in inches and hit enter, and now I can see it's 23.178 millimeters. So that's cool. So the next thing I figured out was I could just use the circular pattern tool. I use the S key to bring up the sketch tool and say circular pattern, and then select the thing that I want to patternize, and then select the point being the center of our board. It defaults to the quantity of 3. They're equally distributed along the diameter, so there really isn't an option to say how far of a distance you want. So as you add more, they just kind of equally distribute themselves. And if you add 18 of them, I know there isn't 18 holes, but if I add 18 holes, and then if I show the Circuit Playground DXF file that we imported, look at the holes. They're pretty much exactly in the right spot. So let me hide that again, and then you can use these checkboxes here to kind of deactivate some of the copies that you don't want. We don't want these two here, so I'm just going to turn these off. And I'll hit OK. Cool. So I'm left with the 14 holes that we need, and I can extrude this out by 1.6 millimeters because that's the thickness of our board. Using our calipers, we can figure out how thick those things are, and that's kind of how I drew the board. So, you would name it PCB, whatever, and I would name this PCB as well. Cool. Now we kind of redo this over and over again for all the components. It might take a little bit, maybe an hour's worth of time, but we will get exact measurements because we're using EagleCAD to know exactly where things are. So that was kind of the only tricky thing, was figuring out where the holes are, but now that we know where the holes are, everything else is kind of simple. So let's go ahead and make this AMD21 chip. Why not? So we know it's a 0 on the Y, or 0 on the X, and then 0.372 inches on the Y. So I'm going to copy that. And then I'm going to make a new sketch. And I'm going to draw on, again, the top plane here. And then check this out. So there is a 2-point rectangle. And the 2-point rectangle kind of sucks for this because you just kind of get a basic rectangle. Instead, what you want to use is the circular rectangle. And that lets you create a rectangle from starting a rectangle from the center of it. So as I click in the center, you can kind of grow out this rectangle. It kind of adds these construction lines for you that are kind of dynamic, and they kind of change, so it's kind of neat. So I know it's 7 millimeters. I can't input the number for some reason. I think it's bugged out for a second. So let me try that again. Nope, doesn't look like it. So let's go ahead and just drop it in and then add the dimensions here. Wow, Fusion is not behaving too well today, but whatever. Okay, so now that we have it 7 by 7, let's go ahead and move this. You can move this around simply by just clicking and dragging this, and then moving it in the right spot in the center, for example. And then what we want to say is use the sketch dimension tool again. I just use the hotkey D on my keyboard, so I don't have to keep going up to the tool panel. So hit D on your keyboard and say I want the center of that rectangle to be a certain distance from the center of the board. So I click that. Right now it's set to 8. I'm going to paste in whatever's in my clipboard. I don't know what it was. Now I'm going to say inches because I know it's an inch. And now I can see that it's 9.462 millimeters. Hit OK, and now I can extrude this out to I think 0.5 millimeters. I think that's the thickness. And instead of hitting join, I'm going to make it a new body so that it becomes a new body. And hey, there you go. We have a SAMD chip. It's so pretty. That's basically how I created the Circuit Playground thing. The NeoPixels are actually kind of using the same method I did for creating the holes, where I just kind of do a circular pattern. So that's kind of neat. Yeah, I think that's about it. Now, creating the enclosure is kind of the same. Well, it's a little bit different, but I think I'm going to save that for another tutorial. Let me see how long this tutorial has been going on, and then we will kind of get back here. Cool. Hey, everybody in the chat room. Thanks for joining me today. Yeah, about 30 minutes. Wow. Yeah, see, that takes 30 minutes just to talk about the components. I've exported DXF from some photo editor into 3D tools. Yeah, DXF is kind of like a standard AutoCAD format that works great for vectors. So it's a vector-based type like format. It says Erdim is saying KiCad and Wings 3D will do it automatically for you. That is awesome, and we have heard from EagleCAD that they are working on something like that, where you'll be able to export out a board file, and it'll translate it into a 3D object automatically for you as well. We don't have that today, so that's why I'm showing you this. That we don't have that today, but here's kind of the hard way to do it. It wasn't hard for me, but it's just, hey, here's how to do it. Okay, that's kind of it. At least you know now how to kind of work within EagleCAD and kind of get the positions and things. Is there a way? George Graves is asking, is there a way to export your 3D file into EagleCAD? Yeah, if your CAD package can export DXF, I believe you can import a DXF into Eagle. So, yeah, I think so. I don't think I have that capability in Fusion. I don't see a way to export a DXF. I might be. Somebody correct me if I'm wrong. Is there a way to export a DXF out of Fusion? Let's see if I have this this sketch. Can I export it? Yes, you can export it out of as a Fusion. So let me go back to Wirecast and show you that real quick. So in Fusion 360, if you want to export a drawing or something, let's say the PCB here, I can right-click on it and say Save as DXF. And as you save that out, you can most likely import it back into Eagle. Import DXF. Wonderful. So yes, it is possible. I just haven't done it yet. I haven't had a reason to do it yet. Yeah. Cool. Well, that's all I wanted to cover today. Just a quick one. In the next tutorial, I guess I will actually show you how to create the simple enclosure for the Circuit Playground. So yeah, if you guys found this useful, if you have any other tips and things like how to use KiCad and Wings 3D to do it automatically for you, let me know in the comments and I'll take a look at it. But that's it. Thank you guys for watching, and be sure to hit that like button if you did learn something. And I will see you guys in the next one. We have a show and tell later tonight. We also have Ask Engineer later tonight. And if you want to support the show and everyone here at Adafruit, you can do so by using coupon code. Today is NeoMini, I believe. Yeah, NeoMini is the coupon code today, so that'll get you 10% off your order. Yada yada, good stuff. All right, guys, I'm gonna start on a new project, and good luck in all your maker endeavors and things. But until next time, I'll see you guys later.